So in problem 8, we've got a very similar question as in problem 7. We're given again a triangle as a preimage. In this case, it's triangle EFG. The transformation is defined as going from x comma y to y comma x. So it's a different transformation, a different triangle, but solved very similar. We are being asked to graph triangle E prime F prime G prime, which is the image of triangle EFG, state the ordered pairs for the 3 prime points, and then answer some questions about the transformation. So let's go about it very much in the same way. Let's determine the coordinates for E, F, and G first. So let's look at E. And again, if we've got points that seem to be between 2 lines, we're going to just say it's a half of the way between the 2 lines. So E is going to be on the x-axis -1, 2, 3, 4, 5.5. So let's call E -5.5, and on the y-axis it's 1/2 or 0.5 up. Point F is going to be on the x-axis -1, 2.5, -2.5, and then it is down 1/2 on the y, it's -0.5. And point G on the x-axis is -1.5, and on the y-axis it is 1, 2.5 in the positive direction, 2.5. So these are our coordinates, and we've got to transform these using the transformation x comma y becomes or transforms into y comma x. So this is just switching the 2 coordinates, right? Swapping them, swapping the places. So let's go ahead and do that. That's not hard to do. So we get, for E prime, we should get 0.5 comma -5.5 just by switching the 2 places. For F prime, we should get -0.5 comma -2.5 by swapping the 2 places. And for G, we should get 2.5 comma -1.5. So we've just switched x and y coordinates in all of these following the rule that we were given. And what we could do is we could write these in the answer spaces. So we have our answers there. Okay. And let's go ahead and plot these to see what kind of transformation we've got. Which, by the way, we've talked about before. Hopefully you recognize it, but let's go ahead and plot these and then rediscover. So E is positive 1.5 on the x and then -5.5 on the y. So that's 1, 2, 3, 4, 5, and then some. It's down over here. This would be E prime. F prime is -0.5 on the x, and then -1, 2.5 on the y. So this would be F prime. And then G prime is positive 2.5 on the x and -1.5 on the y. So we would have G prime over here. So now let us look at what our triangle looks like. We will draw lines between the points and look at our triangle. Now once again, we have an isometry. These 2 triangles are congruent. They're the same shape, the same size. So we have an isometry, and it looks like a reflection. Let's double check. Let's make sure that the orientation is reversed, which is what we expect in a reflection. So E FG here would be counterclockwise, right? We're going from E to F to G, but E prime to F prime to G prime here is clockwise. By the way, we didn't do that on the last problem, but you should check for yourself just to make sure that you're satisfied that orientation is reversed. So this is a reflection, and the equation of the line of reflection is the line y equal x. We did this before. Okay, so I'm going to draw the line y equal x. It's a line that goes through the origin, and it has a slope of 1, so it makes a 45-degree angle with the x-axis and the y-axis too. I just want to try to draw it as best as I can to illustrate the I think that's pretty good. So this is our line y equal x. Let me do that again. Y equals x. Just ignore that. Okay, y equals x. And if we took patty paper and we traced all this, these lines and points on the patty paper, I think you could see that if we folded over the patty paper, the pre-image and the image would lie right on top of each other. Feel free to do that. Feel free to check this, but that's what you will find. So let's go down to the summary here below, and let's conclude some of the discoveries that we made. So the mapping from xy to negative xy is a reflection over the y-axis. And we saw that in problem 7. The mapping from xy to x negative y is, guess what? That's going to be a reflection over the x-axis. Okay, so when you change the sign of x, you're reflecting over the y-axis. And when you're changing the sign of y, you're reflecting over the x-axis. We just did the mapping from xy to yx. That is a reflection over the line y equals x. And then finally, one that we did not look at, but I encourage you to test out on your own, is the mapping of xy to negative y negative x. And that is going to be a reflection over y equals negative x. Okay, and that may be something you want to look at and verify for yourself.